we back to 11A. Okay, back to 11A. Some class might teach that last year, some class might not. We're talking about the area under the graph. Okay, we talk about the area under the graph. We have like a couple of ways to find the estimate area. Okay, find the estimate area. So we have the left endpoint estimate and we have the right point estimate, endpoint estimate. So what is this talking about? So I want to estimate the area under the curve from A to B. Okay, I want to estimate the area under the curve from A to B. I don't know the exact formula yet. Well, you will know the formula like in about 10 minutes, but like we don't know it yet. And we're trying to estimate that. So how do we estimate that? Is we use a left-hand side endpoint triangle, rectangle. So we start from the point A. A is my left-hand side endpoint. So I use A to find the height. And I go for a particular length. Let's say I divide that 1, 2, 3, 4, 5 in 5 pieces. Then B minus A divided by 5 is the width. Okay, is the width for each rectangle. Okay, the width for each rectangle. Okay, and then the height will be FA. Okay, this height will be FA. So we use 5 rectangle to estimate the area. And you can see the area is not the actual area. But like if you divide that into more rectangle, we have more, like the width reduced, the empty area will reduce and reduce and reduce, will be very close to the actual area. So think about, we use 5 rectangles here. How about using 10 rectangles? If you use 10 rectangles, then you will be like really cover most of it. Just a little bit empty. So I'll shade in red. Okay, those areas are the areas hasn't been taken into consideration. Like that's the area like less than that. So those triangle, like triangle shapes. See? But if you have 10 rectangles, then the red area will reduce. Okay, the red area will reduce. You can sketch another graph, you can see the red area reduce. Then if I have 100 rectangles in between A to B, then you will have very, very little red area. It will reduce and reduce and reduce. That's the idea to estimate. Okay, so that's left-hand side. Let's have a look right-hand side. Let's have a look at right-hand side. If you use right-hand side estimation, you start to sketch your rectangle from the right-hand side. So the first rectangle will be made by using FB. Okay, that's the first rectangle. You go for the width that much. And then you draw this rectangle. Then the next rectangle will be using this height. Go for a particular width and draw a rectangle for this one. And then the next one you use is this one. Not here. You go for this height. Go for that same width and go for that. So you just make the rectangle one by one. And you have another new 5 rectangle. Okay, that's the same graph. Okay, those two are the same graph. But we use 2 different estimations. We estimate 2 different areas. You can see obviously the bottom one's estimation is larger than the top one's estimation, right? So what we can say about this is, if we use left rectangle approximation, if you use right hand side endpoints rectangle estimation, okay, if the diagram is an increasing function, let's say it's an increasing function like that, and then we use left rectangle estimation, that should less than the actual area. Can you see that's actually less than the actual area? Okay, less than that. But if it's a decreasing function, so let's have a look. If I sketch a decreasing function, where's my ruler? Okay. If I have a decreasing function, okay, decreasing function from A to B. Okay, say from here to here, I use left-hand side estimation. So that's my first length. I go for this much, Okay, that's my first rectangle, and that's my second rectangle. That's my third, fourth, fifth, and last rectangle. Well, you can see the area is actually more than the actual area. If it's a decreasing function, I use left-hand side estimation, then the actual area will be less than the estimation area. So if it's a decreasing function, left-hand side rectangle estimation will be larger than the actual area. Okay, larger than the actual area. And similarly, if that's an increasing function and we use right-hand side rectangle estimation, the area is larger than the actual area. Larger than the actual area. But if we have a decreasing function, and then we use right-hand side, let's say from A to B, and we use right-hand side estimation, we will have that point, which is here. That's the first rectangle, and the second is here, and the third is here, the fourth one is here, and the fifth one is here. Okay, can you see that's actually below the actual area, So the right-hand side rectangle estimation is less than the actual area if it's a decreasing function. Okay, so therefore the conclusion is here. For fx, if it's increasing, the left-hand side rectangle smaller than the actual area, smaller than the right-hand side rectangle. If fx is a decreasing function, then the left-hand side rectangle is the biggest, and the right-hand side rectangle is the smallest. Middle is the true area. Okay, so for decreasing and increasing, it's totally like totally different. Okay, let's just have a look at that. Example 6. The area under the curve y equals to log ex between x equals to 1 and x equals to 4 is approximately by two shaded rectangles shown below. And what's the approximate area in unit square? Just want to ask you, is this a left-hand side estimation or a right-hand side estimation? Left. But why there's only two rectangles? Well, can you see the width is 1? The width is 1. Can you see 2 to 3, 3 to 4? The width equals to 1. So from 1 to 4 should have 3 rectangles. Is that true? Because the width is 1. 1 to 4. 1 to 2, 2 to 3, 3 to 4. You should have 3 rectangles. But why you only have 2? Where's the first one? Can you see 1 to 2 is 0? That's just no area from 1 to 2 because it's like left-hand side point, you have a y value of 0. So there's no rectangle there. You only have 2 rectangles there. Yep. Yep. And can you see the height? Okay, width is 1. Let's see what's the length. So for this length, that's log E2. For this length, that's log E3. So what you have is log E2 times 1 plus log E3 times 1. So it's log E2 plus log E3. So you have log E2 times 3. That's log E6. So it's approximately log E6. You just find the height by substituting the thing into the function to find the y value. And then you know the width. Okay, you know the width. Normally the width either to be 1 or to be 0.5. Okay, I have a different, like normally I have those two cases, 1 or 0.5. Okay, find an approximation for the area between that to that. Okay, 1 to 5. First, is that a left-hand side estimation or right-hand side estimation? Left. Okay, left endpoint estimation. Okay, left endpoint estimation. So, okay, how many rectangles are there? 4 rectangles. The widths are all the same. I can just add all the height. Add all the height. So for the first rectangle, the height is 4. For the next, you have 7. For the next, you have 12. For the last, you have 19. And you times that by 1. You times that by 1. So 11 plus 19, 30, 42. So the area under the curve should be 42. Okay, have a look at B. What kind of estimation are these? Well, it's definitely not a left-hand side one, but because here is not correct. If it's a left-hand side estimation, this part will be this. Right? This part will be this. This line is not correct. If it's a left-hand side estimation, it should be, there's no this part. So start from here. Because, so this one is a mixed kind of estimation. They just think about some middle estimation, some middle point estimation, or some left-hand side. So from 1 to 3, they use left-hand side approximation, and from 3 to 5, that's a middle estimation. They choose the middle height and then estimate the area. So you don't need to really worry about what kind of estimation is that. You just need to know how to find the area. So the area got a width of 1. So for the first one, you have 7 as height. For the next, you have 5 as the height. For the third and fourth, you have 7 and 7 as the height. And the whole thing will times by 1. So 12 plus 14, I have 26. I have 26. Because the width is 1. Like the height is all the actual, this height, this height, this height, and this height. And they all times by 1. So it basically seems like you take 1 as your common factor, times 1 as your common factor. You need to look at what is the actual width. Okay, you need to look at what's the actual width. If the width is 0.5, you times by 0.5, not 1. Yeah. Okay, let's have a look at this one. Consider the function f(x) equals to 9 minus x squared. Use intervals of width 1 units to find the area enclosed by the function and the x-axis between -2 and 3. Use the left endpoint estimation. Okay, can you see? Use intervals of width of 1 units. Okay, width of 1 units. I don't have my ruler. Okay, let's sketch this graph first. Let's sketch this graph first. Okay, we have 0, 9, and we should have 3 and 3. We have 3 and 3, and then have -2. -2 will gives you 5. So that's the shape of the graph. So what is the area you're trying to estimate? Okay, the area you're trying to estimate is from -2 to 3. So -2 is here and 3 is here. So that's 0, 9, that's 3, 0, that's -2 and 5. Okay, so if we use left-hand side approximation, okay, 1 unit, okay, 1 unit. So the rectangle you can sketch will be, I'll use an obvious color. Okay, that are the rectangles you will use. Okay, that are the rectangles you use. Again, but the thing is, do not really sketch it every time. That's the first time we do this question. I want to show you on the diagram. So can you see, you have how many rectangles? 1, 2, 3, 4, 5. 5 rectangles. Let's see what is the actual height. If we use the left-hand side, area use left-hand side. What I will use is f-2 plus f-1 plus f0 plus f1. How many? 1, 2, 3, 4, 5. And I have one more, f2. And all of these will times by 1. We haven't used f3. If we use left-hand side estimation, we won't use the most right-hand side point. Okay? So similarly, if we use right-hand side approximation, we won't use the most left-hand side point. Okay, we will miss one point, which is either the left-hand side or the right-hand side. It will be opposite. If we use left-hand side approximation, we won't have the right-hand side point. So what I will have is 5 plus 8 plus 9 plus 8 plus 5 times by 1. Okay, 13 times 2 is 26, 26 and 35. So we'll have 35 for this one. Okay, B. So if we try to use the area for the right-hand side approximation, we will start from the right-hand side. We have F3. Then the width is 1, so the next one will be F2. If the width is 0.5, the next one will be 2.5. Okay, reduced by 0.5. And then the next one is F1, F0, and F-1. You won't have the most right-hand side point. Okay, you won't have the most right-hand side point. So F3 will be 0, 0 plus 5 plus 8 plus 9 plus 8 times by 1. 2 times 8 is 16, 16, 25, 25 plus 5, 30. So you have an area of 30. And C is asking you to find the average. So A average equals to 35 plus 30 divided by 2. So 32.5. Well, because I go through all the exam papers and analysis them, find like every year there will be, or every 2 years there will be a question like that in multiple choice questions. In multiple choice, like this can be tested. This can be tested. Like we're very likely to be tested every year in the multiple choice session. Okay, in the multiple choice session. Okay. Have a look at the next one. Consider the function f(x) equals to square root 25 minus x squared. Use intervals of width 1 unit to find the area enclosed by the curve in between 0 to 5. Use the left-hand side endpoint approximation. Okay, 0 to 5, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, so there are 5 rectangles. Left-hand side, okay, use left-hand side. Left-hand side will start from F0. Go for F1, go for F2, and F3, and F4. You won't have F5, and you times that by 1. You times that by 1. Well, you need to know what you're trying to do because we sketch the graph, and the last point we use is the point before the right-hand side point. Okay, not the right-hand side point. F0 is 5. F1 is square root 24, square root 21, 9, square root 16 is 4, 16, and that's plus 3, and you times by 1. And then we have 9 plus 3 is 12, 12 plus, okay, 4 times 6, 2 root 6, and plus square root 21. That's the approximate area. Next one says use the left-hand side endpoint approximation. So the most last point is 5 plus F4 plus F3 plus F2 plus F1, but not F0. Okay, not including the left-hand side point. So F5 is 0 plus 3 plus 4 plus 4 square root 21 plus square root 24. 7 plus 2 root 6 plus root 21. Okay, left or right, like with patterns. You don't need to sketch the graph. Waste of time. If it's not asking you to sketch it, not asking you to sketch the rectangle out, do not do that. Okay, waste of time. Okay, have a read about next question. Find the left endpoint and right point estimates of the area under the curve with equation f(x) equals to 1 over x for x belongs to 2 to 6. Okay, have changed this question, please. Change it to 8 for 8 partitions. Change it to 8. Okay, I don't really need you to calculate this actual area, actual value out. But like say, what 8 partitions tells you? What that tells you, like what this width, the width. So what's the total length for x? 4. So 6 minus 2 over 8 will give you 0.5. So actually, the width is 0.5. Width equals to half. Width equals to half. Okay, so if I use area left-hand side approximation, what I will have is start from 2, so F2 plus F2.5 plus F3 plus 3.5 plus F4 plus F4.5 plus F5 plus F5.5, but not 6. And then remember, that's very important, to times by a half, not 1 this time. We'll times that by a half, because the width is a half. Okay, the width is a half. Do you know a quicker way to do this? There's still, like, if you use calculator, still a long way to do it. Like, it's still a long time to finish that. There's actually a quicker way to do it. We use summation, the sign of summation, and then we say k equals to 0 to k equals to, well, not k equals to, from k equals to 0, 1, 2, 3, 4, 5, 6, 7. Go for 7, and then what you do is f bracket 2 plus 0.5 k times by a half. You just type that into the calculator. Okay, let's have a think. What is it? So summation, the sum is you sum all these terms. When you sub k equals to 0, k equals to 1, k equals to 2, until k equals to 7. You sub 8 times from 0 to 7. You sub 8 times. Okay, so, and those 8 terms will be added together. And that's what exactly the same as the previous line, what this gives to you. Okay, what gives to you. So, what that means, let's have a think. When you sub 0 in, you will have F2. When you sub 1 in, you will have F2.5. When you sub 2 in, you will have F3. When you sub 7 in, you will have 5.5. So it's the last one. So they're exactly the same expression as what you have there. But you just put that into calculator really quick. Okay, just use like 2 seconds to put that into the calculator, rather than plus 8 things together and then times by a half. But remember, times a half here. Because it's all sum relationship, you times the half together with the term. Let's have a think, like in this calculator. Okay, I think it's inside here. Sum is here. Okay, so let's define the f function first. 1 over x. Control VAR f bracket x. Okay, I have defined it, and I will put this in, the summation sign in, and I will put k, well, any variable, like you can put n, you can put a, anything. 0 to 7, that's 8 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8 numbers. And then you put f. F is the previous function we have defined it, bracket 2, start from 2, plus k times 0.5. K loss of 0.5. You have 0.5, 1.5, 2.5, you just keep adding that until you add to like 7.5. And then that number will times by 0.5 as well, because each rectangle will times by the width. And I press enter. That will give you this value. That will give you 1.18654. It is next to the 9 button, next to 9. Can you see here? Here. Click on it. Here. It's okay, you can't get it. It's not really a big thing. It's just a quicker way to do it. Like in exam, well, you can still spend like 30 seconds to press 8 things in. It doesn't matter. Okay, like you're not forcing yourself to learn this. Like if you can understand that, that's just a quicker way to do it. Let's say the right hand side then. So area of right hand side will equals to from F6. Go for F5.5, add to F5 plus F4.5 plus F4 plus F3.5 plus F3 plus F2.5. You will stop here and then times a half. You won't have F2. Because like I realized like the more thing we write and we try to forget, like I shouldn't include one of the endpoints and we make that mistake. So what that can convert to? So that can convert into, okay, I still can keep whatever we have on the top, but here we should have k start from 1 until 8. Because we don't have 2 anymore, the k won't equal to 0. Instead, the k will be 8. The k will be 8. 0.5 times 8 is 4. 4 plus 2 is 6. So the last point should be 6. The first point should be 2.5. So you start k equals to 1 until k equals to 8. So I can easily change that. What's wrong? What's wrong? Go back. You just k. Well, I can use a. Just a equals to 1 to a equals to 8. What's my f? Well, my f is still here. F bracket 2 plus 0.5. Okay, this time can't be k. You need to times a times 0.5. And it's quite similar. Last time is 1.18. This time is 1.019. So which is pretty good. So it's correct calculation. So we have that. Just emphasize this again for calculator use. If you're not using x, y, or z, when you times the letter and the numbers together, you must have the multiplication sign in between. Okay. Sometimes you can't find out any value if you're not putting the times sign in. I can't really remember what's the example, but I clearly remember I did some question and my friend's not putting the sign in and I can't have a value out. And I put the time sign in and you can find answer directly by the test. So remember to put time sign in between number and the letter. Very important. Okay, that's the estimation. Just a little bit calculator, okay, calculator use. Okay, for the next page. Okay, just you don't need to remember, or even read those 2 lines I will explain to you, because even you read, you don't understand what it's talking about. Like it's like very mathematical language to explain the theory. So I will change it into English and then explain it to you. Okay, so basically we do anti-differentiation. We do anti-differentiation at the very beginning. Why we use anti-differentiation? Because we're trying to find our original function. We have a gradient function. And we're trying to find what our original function looks like. I know my f dash x, I'm trying to work fx. That's why we use anti-differentiation sign. Okay, so now we have another meaning for integration, or say like anti-differentiation. So integration will be more appropriate. So there's another meaning. So say if we don't really want to know the original function, we just have a function fx. Okay, that's fx already. And I'm trying to integrate that function and put some number on the top from 1 to 4. The meaning of this will be I sketch my fx function out. Okay, I sketch my fx function out. And from the point 1 to 4, I'm trying to know the area under the curve, in between the curve and the x-axis. I want to know the area. Okay, so not only differentiation not only can do finding the fx original fx function, but also can find the area under the curve for the original function. If you have original fx function, you integral that value and you have 1 and 4 on top. I'll explain what's the 1 and 4 working for. If you have 1 and 4 here, you will have 1 and 4 here, and you will find the area under the curve and then below or above the x-axis. Okay, so it's the area made by those two numbers, x equals to 1, x equals to 4, and x-axis and your actual line, the actual curve. Okay, so the area under the curve. It's finding the area under the curve. Okay, so I will explain to you that this sign, and this sign, that's the summation sign. Okay, we just use it, that's the summation sign. Those two signs are basically very similar. So what's this summation sign working for? The summation sign working for only integer numbers. I will add in a definite, like a particular number of things like 0, 1, 2, 3, 4, 5. Like I can countable numbers. I can add 1, I can say 1.1, 1.2, like 1, 2, 3, 4, 5. But for integrations, it's basically adding infinitely many numbers together. Infinitely many numbers together. So when I say k equals to 0 to k equals to 8, those k value can only be whole numbers. 0, 1, 2, 3, 4. I can't take 1.2, 1.4, 1.5 like that. But like for integration sign, it is a summation meaning, but it's sum for decimals. Okay, sum for infinite many numbers. I can cut the thing as small as I want and can add all of them. It's basically a sum for infinitely many things. Well, let's say, as I explained before, I use 3 rectangles to estimate the area. It's not very accurate. They have a lot of empty space or over like estimate. But think about if I use 1,000 rectangles to estimate this. Doesn't matter left hand side rectangle or right hand side rectangle. It will be very close to the actual area. Do you agree with that? If I use infinitely many rectangles, small like lines to estimate, that will be the true area. Okay, that will be the true area. So therefore, the sum sign on the top will tend into a very, very large number, like infinity. Is that someone else? So infinity, like infinite many numbers, we're trying to add them. So therefore, we come to this integral sign. The integral's meaning and the sum meaning are the same. We're basically adding things together. But 1 is only add for countable numbers, 0 like natural number 0, 1, 2, 3, 4. But for integration signs, we can sum as many things as we want and can add that some decimals as well. So basically means summation, but the summation for infinitely many rectangles in between 1 and 4. So that's the meaning for it. Okay, that's basically what we're talking about for the top 2 lines. Okay, the top, like the thing, I have brackets. So that's what we talk about. And the 1 is called a lower limit. Okay, it's here. Where is it? A is called a lower limit. B is called an upper limit. This integral is called a definite integral. Okay. The previous one is called indefinite integral, and this is called a definite integral. Definite integral means we have limits, upper limit and lower limit. We have 2 values bound the curve, and I want the area under the curve. Okay, we want area under the curve. Well, so without the bound value, the meaningful integral is using f dash x function to find fx. But with the upper limit and lower limit, it means the area under the curve fx in between value a to b. Okay, in between value a to b. So it's very easy to calculate that. It's very easy to calculate that. So ignore the 0 and 1 for a moment first. Ignore that for a moment. You just do normal integrations. Okay, just do normal integrations. So what we will have is 6x minus 2x squared plus 3 over 4x to the power 4. Just do the integration. well, you should plus c for indefinite integral. Okay, before you should plus the c. In this case, we don't need to plus c. We just have whatever we have, and then we put a square bracket. Must be a square bracket. And we put the two limits beside that. We have 0 and 1. We have the two limit on the right hand side, 0 to 1. And the next thing we'll do is we sub 1 into this function first, the top number first into this function. So we have 6 minus 2 plus 3 over 4. Okay, that's one value when I sub 1 in. And I'll sub 0 in. I'll sub 0 into this function. We have 0 minus 0 plus 0. Well, it's quite meaningless, but like I still need to write that out. Okay, that's for when I sub 1 in. The second bracket is when I sub 0 in. I will subtract between that, and that will be the final answer. That will be the final answer. So it's 16 over 4 plus 3 over 4, that's 19 over 4. So for definite integral, we won't have an expression. We will achieve a number, because that means the area under the curve. So basically, I can sketch this polynomial and find the area from 0 to 1. I want the area from 0 to 1. Okay, you sub the top number first. You find the antidifferentiate first, sub the top number first, and subtract the bottom number. But why I don't need the plus c? Because the plus c will involve in both brackets, and when you subtract it, the c just subtract each other and become a 0. There's no point I put a c there and subtract that later. Well, it can involve a c value, but it will be subtract from both brackets finally. You don't even to write it down, just like, because we will know like it will be get cancelled later. One thing is, well, I have sketched a curve. I have sketched that above the x-axis. Let's have a look. If I have another curve below the x-axis, let's say we have something like that. Let's say that's gx, and we have a to b. We want to know this area. So what I can say is, well, it's always from the lower point to the upper point. So lower value is a and upper is b. And I integral gx dx. Okay, the area is always positive. When I talk about area is always positive. But for this one, you will get a negative number. You will get a negative number. Why you get a negative number? Because it's below the x-axis. The area is below the x-axis. You will get a negative number. Well, you can just get rid of the negative sign to say the area is this much. But you will get a negative number. Do not like really surprised like when you get a negative number. It's possible to get a negative number. The negative sign just indicates that you have the area under the curve, under the x-axis. So just go a little bit beyond. If you have, well, I think we'll go to do this again. But like, let's say now I have from the point 0 to, well, I shouldn't go for here. Let's go to here. Go for, let's say that's pi. From 0 to pi. That's a kx graph. Let's say this actual area is A1 and this actual area is A2. This is a pi over 3 or something like that. If I integral from 0 to pi, from the lowest to highest of kx dx, what value I can have? I won't have A1 plus A2. what I will have is A1 minus the area of A2. That's the answer I will get. Because you get cancelled each other, the below one I will count as negative area. The upper one I will count as positive area. So you get like cancelled each other. If you just do that, you get the area, not the actual A plus B. Is A1 minus A2. So how about if you want to find A1 plus A2, you need to find them separately. So I will find from 0 to pi over 3 first for kx dx, and you will have pi over 3 to pi kx dx. Okay, the thing is that's a negative value. That's negative A2. So you will subtract from that. Then that's A1 plus A2. That gives you A1 plus A2. Because like this already gives you a negative number, you subtract the negative number, you have a positive number. So this is originally a positive. This is a positive because it's above the x-axis. This is a negative. That's below the x-axis. Then if you subtract the below one, that's a plus. So it's A1 plus A2. Okay. That's the meaning. Okay, that's more for the meaning. It's more for application. We'll do that later as well. So now what we need to do is just purely calculation. Okay, anti-derived, sub-values in, subtract them. What I want you to have a look is this bit. In summary, if fx greater than 0 for all the x belongs to A to B, the area region contained between the curve, the x-axis, and the line x equals to A and x equals to B, we will have that. So what means all fx greater than 0? So it's everything above the curve from A to B. Okay, that will give you a positive area. Positive area. If fx is smaller than 0 for all the value from C to D, then the region in close by will put a negative sign in the... Oh, well, sorry, I need to change it. C to D here. C to D on the top, not A to B, because I talk about C to D now. So if everything is below the curve like that, from C to D, well, even though you have negative side, it's alright. That's C value, that's D value. That's the same from the left hand side one to the right hand side one, C to D. And I will put a negative sign in the front because you have a negative value, you negative it again, you have a positive one. Okay, so you have that area. Okay, so I'm not going to continue for today. I want you to finish the exercise B, C, D. Okay, 3 exercises. You still have about 5 minutes. You can do it now or do it as a homework. You must do it. Okay, must do it. B, C, and D.